Let's develop and execute a block transfer program for 8051 microcontroller. Here, the word block means the numbers stored in continuous memory locations. And these numbers are to be transferred from those block of locations to another block of locations. We will go through two different programs. In first program, we will transfer the numbers stored in internal data memory to internal data memory. These internal memory locations are different and these internal data memory locations will be different. In second program, we will transfer the numbers stored in internal data memory locations to external data memory locations. Now let us develop the first program. Develop a program to transfer a block of 5 8-bit numbers from internal data memory 20H to 24H to internal data memory 40H to 44H. It means that 5 different 8-bit numbers are stored in internal data memory locations ranging from 20H to 24H, and these 5 numbers are to be transferred to these 5 different locations. The number in 20H is to be transferred to 40H. The number stored in memory location 21H is to be transferred to 41H location, and likewise. This shows the memory map before execution of block transfer program. You can view that memory location 20H holds the first number, say 3CH. You can have any numbers here. Second memory location holds the second 8-bit number. Likewise, these 5 memory locations will hold these 5 different 8-bit numbers. And the destination block, which starts at 40H and ends at 44H, this destination block will have some numbers which we don't know before execution. Now, once we write the program and execute the program, what should happen? All these 5 numbers which are in source block should get transferred one by one to destination memory location. That is, the number in 20H, that is 3C, should get transferred to memory location 40H. The number in 21H, that is 72H, should get transferred to memory location whose address is 41H. Likewise, remaining numbers should also get transferred, and this can be achieved by using a block transfer program. So before writing the program, let us develop the algorithm. Now, one thing I would like to tell you that these all are internal RAM locations, and RAM memory is also called as a data memory. What is the speciality of these locations? These 5 locations, they are continuous in nature. Similarly, these 5 destination addresses, they are also continuous in nature. You cannot transfer all 5 numbers from source to destination. You have to do it one by one. So you have to use a loop concept in assembly language programming. And whenever it comes to develop a program using loop and there is a reference of memory location, then indirect addressing mode is the best addressing mode to be used, because in indirect addressing mode, you will have a smaller and more efficient program when you are writing the program in the form of loops. So let us see. Let us develop the algorithm. First, start, make the initial adjustment and write org directive. Then in second step, we will initialize memory pointer for source. 2 memory pointers will be required because 2 set of memory locations are there. And as far as internal data memory is concerned, we have the freedom of using R0 and R1 register as memory pointer, and fortunately we will require 2 memory pointers and we have the freedom of using 2 memory pointers. So R0 memory pointer, R0 register will be used as a memory pointer to point to the source block. This is the source block. We have to initialize it with the first location. So R0 is made 20H. Similarly, the initialized memory pointer for destination, R1 register will be used as a memory pointer for destination block, and it is initialized with first location of destination, that is 40H. The block transfer activity is to be carried out for 5 times. So we will require a counter, and one register, that is R7 register, will be used as a counter. So load R7 register with the initial value of 05H because 5 numbers are to be transferred. Next is, you cannot take the number from first location and directly transfer it to the first location of destination in one step, because in indirect addressing mode, no such instruction exists. So what you have to do, you have to first take out the first number from source block and shift it into accumulator. So move contents of source location into accumulator. So take this number out and store it in accumulator. And in step 2, move the same number which was taken in accumulator to destination block. So that first number which was taken in accumulator in step 5 is now shifted to the destination location. So one number is transferred from source to destination. So as you are done with 20H location, so increment source memory pointer R0 so that it will point to 21H. Similarly, you are done with 40H location, so increment destination memory pointer R1 so that it will now point to the 41H. And as out of 5 times you have done the shifting operation 1 time, so decrement the counter R7 by 1. From 5 it will become 4, and as 4 is not equal to 0, so jump to the step 5. So it will start transferring the second number. So from step 5 to step 9, this is the part of the loop. So this loop is to be executed 5 times. And once the counter becomes 0, it means that all 5 numbers are transferred. So you have to stop the program. Now let us write the program by using the Keel ID. Double click the Keel icon. The Keel integrated development environment gets open. First step is to create a project. Click project and then click new microvision project. I am already in a 8051 microcontroller folder. Inside that folder, I will type the name of project. I will name the project as block transport. Then click the save. A window pops up which asks you to select the device. I am developing the program for 51 series of microcontroller, particularly for 8089S51. So you can directly search the IC number here, or you can go to the manufacturer, and inside that manufacturer you will find different microcontroller, number of different microcontroller ICs, and in those ICs you can locate the 8089S51 microcontroller. So click it, click OK. It will ask you whether you want to copy the startup code to project. I don't want to copy because it is not needed in assembly language programming. So you are done with creating the project, and this project name is block transfer, and which is displayed in this project workspace. Next step is to create a file by going into file menu and clicking new. This will help you to write or type the program. Before typing the program, let's save this program. So click this save button and save the program with the same name as you have saved the project. You can save it with other name also, but I will save with the same name, block transfer, and I will put the extension .asm because I am going to develop the assembly language program. Click save. So this has changed to block transfer.asm. One more important step is you have to make this program as a part of this project. So for that, you have to right click the source group 1 icon and click on add existing file. Ensure that you are in the same folder where you have created the project. Change the file type to ASM source file. ASM source files get displayed here. This is the source file which I have just created. So I will click it, then I will click add, and then I will click close. Now expand this source group 1, and you can visualize that block transfer.asm file is now the part of project. Once you are done with these initial things, it's time to write the program. First thing is org0000h is written. This assembler directive will tell the assembler to start storing the program in code memory from memory locations 0000h onwards. Next is the instruction, first instruction. First instruction is initialization of source memory pointer. So R0 register is used as a source memory pointer. I will load that 20H starting address of source memory into R0 register by using the instruction move R0, hash 20H. So this will initialize source memory pointer R0 with starting address 20H. Next step is to initialize destination memory pointer. R1 register is used as the destination memory pointer. So load R1 register with starting address of destination block, and destination block starts with address 40H. So move R1, hash 40H will initialize or will load 40H address in R1. Third instruction will be initializing the counter register. R7 register is used as a counter. You can use any register apart from R0, R1 because R0 and R1 use as a memory pointer. I will use R7 as a counter and I will initialize it with the value 05H because 5 numbers are to be transferred from source block to destination block. Now let us actually write the instruction which will transfer the first number from source block to accumulator, and this can be achieved by writing the instruction move a, at R0. So what does this instruction will do? It will take out the number pointed by R0 address. R0 is holding the address 20H. So content of address pointed by R0, that is content of memory location 20H. It means the first number. It is moved to accumulator. So first number from source is moved into accumulator, and the same number is to be copied to the destination block, first address of destination block. So the instruction written here is move at R1, A. So first number which was in accumulator is now moved to the memory location whose address is held by R1. So R1 is pointing to address 40H. So this number in accumulator will be moved to the memory location 40H. So first number is moved from source to destination. Now increment memory pointer R0 so that it will point to the next memory location. It was initially pointing to 20H. Now it will be incremented and it will point to 21H location. Similarly, increment R1 so that R1 register will now increment 40H by 1 so that it will point to the 41H location. And as one number is transferred, decrement the counter by 1 and check whether it has become 0 or not. If it is not 0, then repeat the process. So what I have written? I have written DJNZ R7, RPT. DJNZ executes in two steps. In first step, it will decrement the content of R7 by 1. R7 was initially holding the value 05. It will decrement 05 by 1, that is R7 now becomes 04, and as 04 is not equal to 0, it will jump to the label RPT. So I will write RPT here because this instruction will transfer the number from second memory location into accumulator. Again, the same number, that is second number, is transferred to second destination memory location, and this process will go on. So this loop will execute for 5 times till all 5 numbers are transferred from source block to destination block one by one. Once all 5 numbers are transferred, the counter will become 0, and this instruction will now check whether counter is 0 or not. If counter is 0, then it will not jump to the label RPT. Instead, it will go to the next statement. And as we have transferred all 5 numbers, we will terminate the program by writing the end directive. So this is how a program can be typed in Kill IDE. Now it's time to run the program. The first step is start debug and click on start stop debug session. Do you need any data so as before execution of program? Yes, because I should first load 5 numbers in source memory block, and for that purpose I need to have the memory window. So the memory window can be visualized here. So it can be seen here. If you are not able to view the memory window, then you can view the memory window by clicking the view menu and clicking memory windows, memory 1. Now, as internal data memory is there, I will type I colon and the starting address is 20H. So this memory window will display the memory locations from 20H. Let me resize the memory window so that the 40H location is exactly below the 20H, because I will be able to view the result in a easier way. Now let us input the numbers. In 20H, let me type the first number, which is say 3C. You can have any numbers. I will type the second number. I will input the second number, which is say 72H in memory location 21H. In third memory location, that is in 22H location, I will input the number 19H, and in fourth memory location, that is at address 23H, I will type the fourth number, which is 65, and in 24 location, that is fifth memory location, I will type the fifth number, which is 70, and press the enter. Now once I run the program, all this number which is now in 20H location should get transferred to this 40 location. This 72 should get transferred here. Similarly, this all 5 numbers should get transferred to this destination location. The shortcut key to run the program is F5. So I will press F5 and you can visualize that these all 5 numbers are now transferred to destination location. So this is how the block transfer program can be executed and it can be simulated. To stop debugging, click debug menu and click start stop debug session. So this is the block transfer program which we have just developed and simulated. We will make a minor change in this same program so that we will develop one more program. And which is that program? Here we will develop a block transfer program to transfer a block of 5 8-bit numbers from internal data memory locations 40H to 44H. And these numbers are to be transferred to external data memory locations 2000H to 2004H. What does it mean? It means that the number which is in internal memory location 40H should get transferred to external memory location having address 2000H. The next number which is in 41H location should get transferred to external memory location 2001H. Likewise, all 5 numbers should get transferred from internal data memory to external data memory. So the source block is internal data memory. So R0 register will be used as a source memory pointer. But destination block is external data memory. Hence, I will use DPTR, that is data pointer, as a pointer to external data memory. Now let us go through the memory map. Before execution, internal data memory starting from 40H to 44H holds these 5 numbers. And destination block, that is external data memory, starting from 2000H location to 2004H location holds these numbers which we don't know. Once you develop and execute the program, after execution, these 5 numbers from internal data memory, that is these 5 numbers from source block, should get transferred to destination block. So this content of 40H is transferred to 2000 location. Content of 41H is transferred to 2001 location. Likewise, all 5 numbers should get transferred. And to achieve this, we will make a slight change in the program which we just developed. Now, what change is needed? The source block starts at 40H. Instead of 20H, I will initialize source memory pointer R0 with memory location 40H. The next step is DPTR is used as a memory pointer to point the external data memory. Remember that DPTR is a 16-bit register which points to the data memory, and as it is a 16-bit register, so it should be loaded with 16-bit value, and the starting address of external memory is 2000H. So DPTR is loaded with 2000H location. 5 numbers are to be transferred, so I will keep R7 counter as it is. The next thing is that I have to take out the first number from source memory and store it in accumulator. So first number is in 40H location. So it is taken out and copied into register A by using the instruction move A, @R0. So it will take out the first number from 40H location and it will copy it into accumulator. Now the same number which is now in accumulator is to be shifted to destination memory location 2000, which is pointed by DPTR. So I have to write a MOVX instruction. Remember this change, that instead of move we have to use MOVX instruction when we are dealing with external memory. This X stands for external memory. External memory is pointed by the memory pointer DPTR. So I will type DPTR here. So what does this instruction will do? It will copy the number from accumulator, that is, it will copy the number from accumulator into external memory pointed by DPTR. So DPTR is pointing to 2000H memory location. So it will shift the first number from 40H location to 2000H location. As you have shifted one location from source to destination, now increment the source memory pointer to point to the next location. So increment R0 so that it will point to 41H. Similarly, increment the DPTR so that DPTR will now get incremented by 1. So from 2000H, it will become 2001H. So it will point to the next or second memory location of destination, and decrement R7 by 1 so that counter will decrement by 1 and it will jump here. So this part of loop will get executed for 5 times. And once all 5 numbers are shifted from internal data memory to external data memory, counter will become 0 and the program will get terminated. So save the program and click the build target and check for any errors. As there are no error, I can proceed for debug session. So I will click debug and then I will click debug stop debug section. So the memory window is already. So first location 40H will be stored 11H. Second number 22 will be stored in 41H. 33 will be stored in 42H. 44 will be stored in 43H, and last number 55 will be stored in 44H. Now before running the program, what should be done? I should have one more memory window so that I can visualize the result. So go click view, click memory window and memory window 2. So this is the second memory window. You can separate these memory windows like this. Now let me zoom it. So this second memory window where I am going to observe the result is the external memory. So hence X is typed, it is followed by colon and 2000H and press enter. So this is the address where these 5 numbers which are now in source memory should get transferred. So let me minimize, let me check it. So this is memory window 2, this is memory window 1 I will resize it again. Let me resize the second memory window. It is resized, and now it's time to run the program. So you can run the program by clicking the debug and run. From here, you can visualize that these 5 numbers which were in these 5 different memory locations in internal RAM are now shifted to these destination locations. The number which is in 40H internal RAM is now shifted to 2000H location, which is external RAM location. Similarly, the remaining 5 numbers are shifted. Thus, we have developed the program and we have simulated the program to transfer the numbers from internal data to external data memory. So that's it for now. Hope it was helpful for you. Thank you.